Alright, welcome back. So we are now in the part 2 of this topic. So that is the problems in geodesy. Problems of geodesy generated from the partially supplementing Helmholtz definition. So from the Helmholtz definition, ni-arouse ni ang problem sa geodesy. So Helmholtz definition is the science of measurement and mapping of Earth's surface. When we talk about Earth's surface, it deals with the figure, figure of the Earth. Kung if ever we are going to talk about Earth's surface, kambal din niya sa iyahang term is ang figure. So the problem of geodesy is to determine the figure and external gravity field on the Earth and of other celestial body as functions of time, as well as to determine the mean Earth ellipsoid from parameters observed on the exterior to the Earth's surface. So again, pag mo yung tag-Earth surface, kambal din niya ang figure. And besides from the figure, the problems are aroused from the determination of the external gravity field. So, ang pag-determine sa mean Earth ellipsoid is their one main problems in geodesy. So, anong Earth ellipsoid man, sir? It's because ellipsoid or ellipse has a parameters, and out from the parameters, we have formulas to determine the specific coordinates of the point. It's because here in geometric geodesy, we are dealing with the ellipsoids. We are treating Earth as a ellipsoid. So when we say figure of the Earth, there are two types: the physical and the mathematical. For physical, let's define what is the physical surface. The physical surface of the Earth is the border between the solid or fluid masses and the atmosphere. So, let's imagine that we are looking into the Earth in the side part. So, we are going to trace the line of the solid part. Then, if we are going to go to the oceans, so ito pong i-trace ang line sa oceans. And pag makonect na ito na siya tanan, that's the physical surface of the Earth. And the problem here in physical surface is the determination of ocean floor. Since ang atong matrace is ang surface lang sa water, but the question there is unsa day kalawomon ang kanang diya nga part, diya nga portion para ma-determine nato ang kalawomon, no? So determination of the ocean floor being the bounding surface between the solid terrestrial body and the oceanic water masses. So the problem there is ang pag-determine sa surface nga nag-separate sa fluid and the terrestrial part. Next is the problem is the irregular surface of the solid Earth. For example, the continents and the ocean floor. So kung ato ang i-imagine na wala o nato tanan ang tubig sa Earth, so say forma niya, so it's very irregular surface. So out from that, if you are going to treat that, so it is incapable of being represented by simple mathematical relation. So dili nato siya directly makuha dayon, or nato siya ma-represent through mathematical formulas or mathematical iterations and so on. Next is, we are going to consider that the ocean surface is the 70% of the Earth's surface. So it possesses a simpler principle of formation. So mo ni siyang illustration for physical. So from the light blue yung sa taas, so that's the Earth's surface, mo nang terrain nga ato ang ginatindugan. So padulong siya sa oceans or seas. From the sea surface napa siya distance, from the sea surface padulong sa seabed. So ang pag-determine ana nga height is ang problema sa physical geodesy, sa physical na aspect, and ang kanang geoid, so muna siya ang mo-approximate sa Earth surface and the ellipsoid. Ano na may ellipsoid, sir? Again, out from the geoid surface, si ellipsoid ang represent ana nga geoid. For mathematical, under a certain assumption, they form a part of a level. So gitawag na niya is equipotential surface, or the surface of constant gravity potential of Earth's gravity field. So this surface is being extended under the continents and then identify it as a mathematical figure of the Earth. So again, ang kaning mathematical figure is nagamit siya, of course, mathematical formulas and iterations. So ang buhaton na niya is from the sea surface, i-extend niya to the land part or the continents. Tapos i-gidab or i-identify niya as katong surface is a mathematical figure. So according to GB listing, so those mathematical figure or designated as the level surface is called geoid. So patumoto siya atong discuss ganina. Kung nakita ninyo sa video, si geoid. So ingani ang forma ni geoid. From the sea surface, extended padulong sa continents or sa landforms. So mao na siya si geoid. So balik taan ni no. So geoid from the sea surface extended padulong sa earth surface. So ang kanang dark blue mo na siya si geoid. So geoid is what we call the surface of the earth in a geometrical sense. It is nothing more than that surface which intersects everywhere the direction of gravity at right angles, and part of which coincides with the surface of the ocean. So that's according to C.F. Goss. So every part of those geoid point, ang iyahang direction sa gravity is right angle or perpendicular. So nga na example sa geoid. As a whole, the physical aspect of the problem of geodesy follows the consideration of the Earth's surface and the geoid as a bounding surface of the Earth's gravity field. Also the consideration of the external gravity field, as may be described by the infinite number of level surfaces extending completely or partially exterior to Earth's surface. So again, no, consideration of the Earth's gravity field. So balik tayo nga figure. So we have Earth's surface, geoid, and ellipsoid. To have the relationship between these surfaces, here it comes the reference system. So sa reference system are being introduced in order to describe the motion of the Earth in space and surface geometry and gravity field of the Earth. So in short, to have relationship with these surfaces, here it comes na i-introduce si reference systems. So we have the capital H. So ang tawag ng capital H is orthometric height. Orthometric height of the point is the distance along the plumb line from the point to the geoid. So considering you have nagstand ka diha sa kanang part babaw anang H nga nay arrow. So diha ka nagpindot. So ang imong orthometric height is ang distance gikan sa imong gitindugan padulong sa geoid surface, which is the mathematical figure of the Earth. So it is the distance again, the distance along the plumb line. When we say plumb line, your direction of your gravity padulong sa center of the Earth. So parallel na siya. So ang kana nga line is ni parallel na siya sa katong direction sa imuhang gravity towards the Earth. H is for orthometric height. Next is we have next is we are going to have the definition of the geoid. So next is the definition of geoid. Again, geoid is an imaginary surface that coincides with mean sea level in the ocean and its extension through the continents. So, ito na nag-discuss ganina. And another element is the ellipsoidal height. So, ellipsoidal height is the h. So para mas ma-appreciate pa ninyo si reference system, let us recall first the two general classification of surveys. So I hope and I assume that you already know this one, no? The definition of this one. It's because it was already taught to you during your lower geodetic engineering subjects. So we have two general classifications. So we have geodetic surveys and plane surveys. So let's differentiate between the two. So geodetic surveying takes account the true shape of the earth, which employs the principles of geodesy that nga atong gistudihan karon, no? Si geodesy. And also, this surveying is a highly precise. Line of any two station is considered spherical or curved. Na siya curved, no? And triangles that was formed by any 3 points of this surveying is considered spherical. So, when spherical, curve. No? And angles of the triangle are also considered spherical. So, again, may angle na involved. And geodetic surveying can be extended over large areas. And the output of the geodetic surveying are great importance in furnishing precise points of reference to which multitude of surveys of lower precision may be tied. So, ang output aning geodetic surveying maoy gamiton nga basis for the lower precision na mga survey such as property surveys or lot surveys. Diha mo tie up, no, sa output aning geodetic surveying. For plane surveying, so this means the surface of the earth is considered as a plane, no, from the word itself, plane, flat lang tanan. So dili siya ellipsoidal, dili siya spheroidal or ellipsoidal, kay naka-neglect siya ang curvature. So curvature of the earth is ignored and the line joining any two station is considered to be straight. So unlike sa geodetic surveying nga, spherical or curved siya. So for triangles formed by any 3 points is considered as plane. Triangle lang siya. While as compared to geodetic surveying, spherical siya. And the angles of triangle are considered plane angles and carried out small areas, which is less than 250 kilometers squared. So mosulod na karon si reference system diri sa geodetic surveying. It's because it implies the principle of geodesy. And reference system is under the topics for geodesy. So let's take a look for this example, no. Kung sa kalainan ni geodetic and the plane survey, no, kanang violet, so that is a level of equal elevation when we talk about plane survey. Okay, flat naman siya, so straight line lang siya, horizontal plane. While sa geodetic surveying, as you can see, the line of equal elevation is kanang green na portion. So, ang kana siya nga line is equal ang elevation na niya. It's because geodetic surveying or geodetic survey takes into account the curvature of the earth. Here it comes na musulod si reference system na knowledge na itong i-discuss ganina. It's because in geodetic surveying, a reference surface is introduced in order to distinguish curvilinear surface coordinates and heights. No? So from that part, no, again balik taan ni na figure, so natay terrain surface, so man atong gitindugan. So considering ang point na ay part na point diya sa terrain surface, so ang ellipsoidal height, no, na siya ellipsoidal height from the point to the ellipsoid. Ang geoidal undulation na n is the difference between the ellipsoidal and geoidal height or orthometric height pala. So, orthometric height is from the point to the geoid. So, because of simple equation of this simple equation, a rotational ellipsoid flattened at the poles is better suited as such as reference surface than the geoid. So, muna akong i-discuss kanina, para mas dali ang pag-calculate or ang simple na equation, para mas makaderive og another formula to get the positions of the specific points. So, a rotational ellipsoid daw kuno, which is flattened at the poles. So, inyo imagine nga, ellipse siya na ay flattening sa poles. So, paana siya, no, ang iyahang flattening. So, it is better suited such as reference surface than the geoid. It's because geoid is very complicated. It's because of its irregular surface, no? So, which is determined by an even distribution of Earth's masses. Particular significance is given to a mean Earth ellipsoid, which is approximating the geoid, no? So, again, si ellipsoid na karon ang gamiton for the geometric calculations of the Earth. It's because of its simple equation as it's stated sa kaninga slide. No? So, i-approximate niya si geoid. So, from that, so as you can see, naa siya surface of the Earth kanang sa color na niya green. So, and also, ang kanang blue is the geoid. Si geoid, diba, from the sea surface, padulong din sa continents. So, natay geoid, then si ellipsoid now is ang mo-approximate ana niya nga geoid. So, out from that geoid surface, himuan siya o ellipsoid. So, that ends for the part 2 of this lecture. So, if you have question, please free to ask me in the LMS and for the Facebook page. Alright, let's go to the part 3 of this topic, which is the branches, subdivisions of geodesy. So we have first branch of geodesy, which is our subject, geometric geodesy. Its concerned is the describing of location in terms of geometry. Consequently, coordinate systems are one of the primary products of geometrical geodesy. So the main output of this subject is the coordinate systems and determination of the locations in the specific point of the Earth. Next sub-branches is the physical geodesy. So this is the next subject that you are going to take up in geodesy, the physical geodesy. It concerned with determining of the Earth's gravity field, which is necessary for establishing heights. So the main output for physical geodesy is you are going to study about the different gravity fields and different heights para you can establish the z coordinate of the three-dimensional, which is the heights. Next is the satellite geodesy, the third subject that you are going to undertake in the geodesy subjects. It is concerned with the using of orbiting satellites to obtain data for geodetic purposes. So, from the word itself, satellite is the one that is artificially put in the outer space to observe the Earth. So, out from the orbiting satellites, we can communicate with them so that we can obtain data for our geodetic purposes, such as satellite images, and also for the determination of the exact location. Kanang ginagamit na GNSS receiver. So GNSS receiver, mo-communicate na siya sa satellites, and the satellites will give data to the GNSS receiver to give the exact location. So another definition for branches of geodesy is from the Lopez, Sir Lopez of GAP Academy. So according to him, geometric geodesy is concerned with the definition of the Earth using the properties of an ellipsoid of revolution, and other related geometric concepts. Physical geodesy, according to him, is concerned with the study of Earth's gravity field in order to determine its true size and shape. And for satellite geodesy, concerned with the using of satellite positioning systems in determining position and defining the Earth's size and shape. And according to Lopez, there is another branch of geodesy, which is the geodetic astronomy. So, geodetic astronomy is concerned with the study of determining position using the measurements made by the observing celestial body. So kanina si geodetic astronomy, it's a branch of geodesy na deal siya on locating or determining locations of points in the surface of the Earth using the celestial bodies rather. So celestial bodies consist of stars, quasars, and other heavenly bodies. And we have also integrated geodesy. So it is a relatively new branch concerned with the unification of physical and geometric components of the Earth. So there is an integrated geodesy, i-combine na si geometric o si physical. Positioning finds application also in the realm of hydrography, boundary demarcation, engineering projects, urban management, environmental management, geography, and plantology. The geokinematic finds application also in ecology. Thus, geodesy has a symbiotic relation with some other sciences. So we have strong relation. We have here the strong relation of geodesy to other sciences. First is mathematics, which is the fundamentals, the physics, computer sciences, and we have also overlapping principles with other sciences such as geophysics, which is the study of global gravity field. So overlap siya, it's because in geodesy we have physical geodesy, which deal more on the Earth's gravity field. And in fact, the blurred boundary between these two sciences, the geophysics and geodesy. And we have also here the weak relation to other sciences. We have space science, the astronomy, oceanography, atmospheric sciences, geology, and etc. So here is the illustration of geodesy and its relationship with other sciences. As you can see, the computer science, physics, and mathematics, which is the fundamentals, is the root. And the output of these three sciences can be a mapping, urban management, engineering projects, boundary demarcation, ecology, environmental management, geography, plantology, and hydrography. And also, it has a interchange or related sciences such as the geology, atmospheric science, astronomy, geophysics, space science, and oceanography. So I guess it ends with the part 3 of this lecture. So see you for another video for part 4 and part 5 of this topic. Keep safe everyone, and good day.